Hello everyone, I'm Danny Alexander, I'm the head of UCL Computer Science. I'm just going to give you a short introduction to the topic, our institution and department, and the computer science degrees that we offer at UCL. Computer science really is the discipline that will define this century. It's actually quite a young field. It's been around for less than an average human lifetime. My parents were born before the first real computer appeared in the late 1940s, and they're still alive and well, by the way. But what amazing progress we've made since those first computers that occupied a whole room and with a fraction of the power that we can now hold in our pockets. Over just a few short decades, integrated circuit technologies, initially developed for the Apollo space missions, allowed those room-sized computers to evolve rapidly towards compact personal computers that could be widely manufactured and sold into millions of homes. The internet first appeared in the early 1970s. 20 years later, it had revolutionized communication and given birth to some of the biggest international companies the world has ever known. The last decade has seen the emergence of AI, which is now itself underpinning a new industrial revolution as technologies such as self-driving cars, robotics and large language models become a practical reality. But this is just the beginning. AI is going to continue to revolutionise the way we work, the way we learn and socialise, our healthcare systems, finance, defence, the way we set the law and even govern our countries. Forthcoming technologies, quantum computing for example, are going to open whole new vistas of possibility. Realising the potential of these emerging capabilities demands all the core skills of computer science. Machine learning, of course, is a key technology for AI, but delivering AI systems also requires software engineering, network systems, information security operating systems, all the other expertise that a computer science degree programme offers to you. Why UCL? So UCL has a unique culture set through values laid down from its very beginnings. The utilitarian philosopher Jeremy Bentham founded UCL almost 200 years ago. It was founded on a radical new idea of university for all, and that went very strongly against the restrictive entry requirements for the traditional universities at the time, which were pretty much limited to male members of the Church of England. UCL was the first to admit students regardless of race, religion and gender. And it was the first to appoint professors of a variety of now commonplace academic subjects, such as medicine and law. And it really strongly retains that progressive and multidisciplinary nature to this day. A good illustration of that philosophy is the new UCL East campus on the Olympic Park near Stratford. It was built as a space to work on big transformative multidisciplinary projects that can only be tackled by collaborative groups with diverse expertise. We as computer science have a strong presence there, for example through our robotics labs and our robotics and AI degree programme, as well as an activity called the Global Disability Innovation Hub, which develops assistive technologies for disabled people. Some vital statistics of UCL. We ranked second in the UK for research strength in the last Research Excellence Framework. That's a national exercise the UK runs every 7 years to evaluate university research across the whole country. And we're regularly in the top 10 of world university rankings. What that means is that at UCL, you'll be taught by and get to work with world-class experts at the top of their game. With almost 10,000 academic staff and over 50,000 students, we're the biggest campus university in the UK. We're also a complete university in the sense that we cover all academic areas, the full range of mathematics and sciences, but also medicine, arts, humanities, laws, and even the study of education itself. That size and diversity gives a unique experience. Pretty much any side interest you have or activity you want to get involved in, you can find it at UCL. Finally, from me, a word on the degree programmes we have in UCL Computer Science. Our two core computer science degree programmes are the 3-year BSc and the 4-year MEng. They share the first 2 years, which focus on core computer science capability. The last year of the BSc and the last 2 years of the MEng provide opportunity to specialise in topic areas of interest and to work with individual research projects with research staff in the department or external partners such as industry. The mathematical computation degree is run with the maths department at UCL, and as it sounds, it's 50% maths and 50% computer science, and it caters really to those with a more theoretical mindset. Finally, the MEng in Robotics and AI is a relatively new programme that started just 2 years ago. As I mentioned already, it's based at UCL East, and it draws on computer science, of course, but also various other engineering disciplines, electronics and mechanics, for example, to combine all the core technical skills needed to deliver robotic and AI systems of the future. That's all from me. I'm going to hand over to some other members of the team to talk in more detail about our department and the degree programs we run.
Hello. I will introduce you to our UCL's undergraduate degree in computer science. My name is Ivana Drobnik and I'm a professor of computational healthcare and the program director for the BSc and MEng in computer science. In this presentation, I will tell you a little bit about computer science and why it is an exciting field to study, our department, and our undergraduate program. Computer science is the study of computers and computational systems, primarily software and software systems, including theory, design, development, and application of these. And there are many different areas in computer science, but some of the principal ones are artificial intelligence and machine learning, which develop computer systems that can learn from data and recognize patterns and make decisions. Then we have computer systems and architecture, which is the study of structure and behavior of computers, including the design of processors, memory, and other hardware components. We have algorithms and data structures, which is a study of efficient ways to store, retrieve, and process data. And we also study human and computer interaction, which is the design and evaluation of user interfaces and the study of how people interact with computers. So these and many other areas are being studied in computer science. And computer science itself is a very fast evolving field. I mean, in 1948 was when the first and one of the earliest computer was created, and it was here in the UK. And then through the 1990s, when Amazon came along, and 2000s with Facebook, with PayPal, Twitter, and iPhone, they all revolutionized our lives. Then from 2010 and onwards, we have artificial intelligence and many different ways it has been changing the world. It became the world winner in chess, the world winner in Go, and was predicting very complex protein structures better than any other human could ever. And finally, as of very recently, we have ChatGPT, which is an interface which allows us to interact and ask the artificial intelligence directly questions for which we get extremely comprehensive and very knowledgeable answers. So computer science has truly changed the ways we are doing things. In the future, it's hard to imagine any field without it. Digital health, robotic surgery, AI in law, education and finance, home robots, precision agriculture, defense. Most importantly, computer science will help us face some of the biggest world challenges, such as climate change, plastics, sustainability, and antimicrobial resistance. So it's an incredibly impactful, timely, and diverse field to study. Our Department of Computer Science is one of the biggest departments at UCL. It is the second in the UK for research power, and it's first in England. It has extremely close connection with the world's megatech, with Google, DeepMind, Microsoft, Facebook, TikTok, and some of which of these were founded by our own UCL alumni. It also has close connections with various world-leading London hospitals, finance institutions, schools, and industry. It excels at interdisciplinary research, teaching with national and international impact, both at the undergraduate and graduate level. Our department has made a great national and international impact with its research. Our research in artificial intelligence is one of the best in the world. Our Center for AI closely collaborates with DeepMind and Microsoft on new challenges in AI. Our work in computer graphics, vision, and imaging enables truly immersive experiences as real as real. Our work on logic, system design, and automatic fault correction ensures correct and efficient implementation of evolving software systems. And our digital health research empowers individuals to monitor and maintain health and well-being. One of our big research areas in graphics and visualization and work led by computer science academic Professor Lourdes Agapito and her team led to the creation of an AI video generation platform and the company Synthesia, which allows users to create AI-generated videos by simply typing text. The platform was used to generate videos of David Beckham speaking 9 languages as part of the campaign of raising awareness about malaria. In 2023, Synthesia became a unicorn, meaning it is valued at $1 billion, and it is just one of the many startups that we have created in our department, some of which with our undergraduate students. Our undergraduate degree program in computer science can be studied as either a Bachelor of Science, in which case it lasts 3 years, or as an Integrated Masters of Engineering, MEng, in which case it lasts 4 years. These 2 programs start equally and are exactly the same during the first 2 years. They then diverge at year 3 in a way I will explain later. In the first 2 years of the program, we cover the foundations of computer science. At year 1, we cover principles of programming, theory of computation, object-oriented programming, and algorithms. And then at year 2, we cover computer architecture and concurrency, logic, software and systems engineering, and security. We also cover mathematics, including discrete mathematics, as this is essential for the understanding and applications of computer science, in particularly areas such as logic or machine learning. Very important element of our program is a programming tutor scheme during year 1. At the beginning of their degree, our students come with a range of different levels of programming expertise, from beginners to high-level experts. We invite applicants of all levels of programming experience, and our commitment is that by the end of year 1, all students will be at equal footing in terms of their programming ability. So programming tutor scheme is an additional support mechanism in which our experienced year 3 and year 4 students mentor, tutor, and guide our year 1 students on hands-on programming. This is not only an opportunity to hone on your programming skills, but also to meet other fellow students throughout the degree. As part of the first 2 years, we also offer 4 modules for our Integrated Engineering Program, IEP. So IEP is offered jointly across 8 different departments of Faculty of Engineering, to which computer science belongs. Mechanical engineering, electronic engineering, chemical engineering, management science, amongst others. But these modules are meant to teach you in an interdisciplinary environment a wide range of skills in addition to academic knowledge. Engineering challenges in the first year teaches you to work in interdisciplinary areas and to work in teams which are comprised of different students coming from these different areas. It also teaches you practical challenges, such as, for example, building a robot. Design and professional skills teach you computer science design cycle, engineering drawing and computer-aided design, programming and risk assessment, but also communications, ethics, teamwork, and leadership. In scenarios, you will get week-long projects where all else stops and you and your team focus on a technical engineering design project. And finally, the 4th module are the minors. So each of you will choose a minor pathway, which is 3 modules, 1 at the 2nd year and 2 at the 3rd year. And these minor pathways are in a different area, in a different subject, and it's your opportunity to try something else and apply computer science in a totally different area. So for example, some of the minor pathways that we are offering is in ocean engineering, in regenerative medicine, in intelligent systems, connected systems, robotics, and also in finance and accounting. So this is your opportunity to hone on the skill that will maybe later on lead into a particular career direction. After year 2, the final decision on which pathway the student will choose to go, like either BSc or MEng, needs to be made. So it is possible that at the beginning of your degree, you choose one of these pathways, but at the year 2, you can change your mind and then decide one of these ones, depending on what you're interested in at that point. So the third year is the final year for the BSc students. It contains 2 core modules, computability and complexity theory, and compilers. It also contains the 2 modules from the IEP minor pathway that you started in the previous year. And very importantly, it also has an individual project. So individual project is your opportunity to work for 2 terms in a research group or one of the academics that we have in our department. So these are world-leading academics. So in those 2 terms, it is very likely you'll be working on something very novel and very current in their area of research. And very often at the end of these 2 terms, some of the students have an opportunity to publish a paper with that academic with whom they worked, or maybe to go on a conference, or maybe that collaboration will lead to a totally new research area or an idea. But certainly it will be an opportunity to create a close relationship with the academic and the research group that you're working in, and potentially offer of a summer research project or an internship. Finally, BSc at their third years choose 2 optional modules from our wide selection of optional modules, and spanning areas of artificial intelligence, vision and graphics, human-computer interaction, computer systems and networks, and information security. If you choose to pursue an MEng in computer science, your third year will look a little bit different. So at this level, you will have a few more of the core courses in order to widen your foundational knowledge of computer science. You will also have 2 IEP minor modules that are your pathway started at year 2. But you will not be doing your project at this year. You will only be doing 1 optional module from the selection I mentioned earlier. That is the same for the BSc students. Final year project for the MEng students is done at their 4th year. And the project is done in a similar way as I described previously for the BSc students, also in a research environment and with an academic and their research team. But what is really important at this 4th year for the MEng students is that they will have an option to choose between 6 different modules amongst all the different masters that we offer at our department. So this year is a master's degree level year. And the masters that we are offering in our department are in artificial intelligence, vision and graphics, information security, in quantum computing, robotics, and in finance. So you will have an option to choose 6 different modules in one of these masters or across different masters, depending on your interest and where you would like to specialize and kind of elevate your knowledge of computer science to become more advanced in a particular area. A special part of the degree for all of the students is our Industry Exchange program, IXN, which is done at year 1 as part of your systems engineering module or via summer research projects. This is a unique program which we offer in collaboration with a range of industry partners. The program is designed to enable students to take part in real-world problem-solving projects. And the projects stem from a range of different areas like healthcare, charities, finance, and from a range of different industry partners. So currently we are collaborating with Microsoft, IBM, Facebook, Chanel, Cisco, Credit Suisse, and many others. So industry partner suggests a project and acts as a client with a set of requirements. And our students work in a team and over 2 terms deliver a final product that actually then gets implemented in the company with which they collaborated. So this module is a great opportunity for the students to experience working environment with some of the industry giants. And also it very often ends in longer collaborations and offers of internships. So one of our well-known projects that is and our longest running projects on the IXN program is actually Motion Input. So Motion Input is done with Microsoft, IBM, and Intel. Its aim is to develop a software that allows users to control their PSC with just using their hands, face, full body, and speech. It's a true touchless computing. Our students have made the first prototype of this software 3 years ago, and then the software has been growing from strength to strength ever since. It won multiple awards, and it is included now in the Microsoft suite of apps. So do please point at these codes if you would like to learn more about it. So in the description of the program so far, you have noticed that I often talk about teamwork and problem solving and a range of different ways of teaching, which is additional to just traditional teaching. And this is really a key and a very important way of how we do teaching here at UCL. In the description of our program so far, you have noticed a range of different ways of teaching, in addition to the traditional teaching methods. The program was designed to spark your mind, and instead of being told what you need to know, to memorize it and then to test it in a problem, we flip this around by assigning the problem first, then you identify what you need to know, and then learn and apply the problem. This not only improves your problem-solving skills, which are fundamental in a job environment, but also is much more fun and interactive way to study. In addition to this flipped classroom, as we have shown, we offer lots of practical work, believing in learning by doing, not just reading, teamwork, but we also have a good mix of courseworks and exams, research projects, high-tech simulations, making videos, and teaching you to make portfolios, which is great for coursework, but also later on in a job environment. Our teachers are a mix of leading UCL computer scientists, professional teaching fellows, and computer scientists connected to leading companies such as Google, Microsoft, or DeepMind. In addition, here at UCL, we are well known for bringing our science to your studies. We bring our real-world scientific experience into the classroom, both via the material we teach, the world-class academic research assistants who are all on your research projects will be there to guide you, and you'll be able to learn some of these research methods directly from them. We also host students who do their final year projects in our research teams and during their summer projects, and they often end up being part of groundbreaking discoveries. A number of our students have co-authored scientific papers and or have been part of startups which they joined or themselves started. We are committed to develop computer science graduates with strong computer science foundations, deep insights, wide application range, and able to tackle and solve problems. This will give you a strategic advantage when applying for jobs. And there are so many different job opportunities that you can choose from. You can choose to become a data scientist or a game developer, or a software developer, or a web app developer, network engineer, machine learning engineer. Also you could also just choose to stay at a university and then do a PhD and maybe become an academic later on in life, like myself or some others. As I mentioned earlier, the skills that we teach you are highly employable. We don't just teach you the computer science knowledge, but also leadership, teamwork, problem solving, and critical thinking, debating and persuasion. And all of these are really important regardless of which profession you go to. Our students also receive a bespoke support by our UCL careers team, who will guide you and provide access to a wide variety of resources. So it is really truly tailored the path for you with computer science. After their degree, our students end up working in a range of places, from tech industries such as Facebook, Amazon, or TikTok, to healthcare and finance. Some of them choose to do their PhDs and stay in academia. It's not always what our students expect when they start this. Some come wanting to do finance later on, but end up doing ocean engineering. And some come wanting to work in tech industry, but end up becoming a PhD student and going into academia. And some find other talented entrepreneurial friends on the way, and they start their own startups. And that is the beauty of this degree. When you start, you don't need to know what and where you would like to end up and what career you would like to pursue. The degree teaches you the fundamentals that you need of computer science and offers many other skills and different pathways to study and tailor to your interests. So your passions and your talent will ultimately lead you to your own individual path and the career of your choice. Thank you all for listening. More information and the applications for the computer science program are available at these links that are included in this slide. Regardless of where you choose to go next, I wish you the best of luck. Thank you.
Hi everyone, my name is Kiran Ahmed and I am the EDI officer at UCL Computer Science. Today I'll be speaking to you about student funding at UCL. Going to university can be expensive with a high cost of living, but there are several financial options available to help pay for fees and living costs while you study for your undergraduate degree. Student Finance England offer tuition fee and maintenance loans for UK home students. UCL also offers generous financial support packages. Bursaries and scholarships can be found using our UCL Scholarships Finder tool. In addition to scholarships, there is an undergraduate bursary and funding available for disabled students at UCL. Read more about these and the eligibility criteria on our web pages. UCL Computer Science launched its first undergraduate scholarship called the Aspire Award. These new scholarships are for Black British or mixed Black British students. The scholarships cover the full tuition fee and offer a very generous living allowance of around £20,000 per year and a one-off equipment grant of £1,500. So you can focus on your studies and not worry about finances. The Aspire Award scholarships are available for all of our undergraduate programs. Scholars will also receive mentoring, personal support and careers advice throughout their studies from our partnership organisation, the Windsor Fellowship. To make an application for the scholarships, first complete a UCAS application with UCL Computer Science as your first choice. And once an offer has been made by the department, you'll be invited to complete an Aspire Award application form. For more details, please visit our web pages for the eligibility criteria and frequently asked questions. Thank you.